All right, thanks for coming. I guess we can start right away. So we all want a better experience for our users. And animations is a crucial ingredient for providing a better experience. Subtle contextual animations engage users, reinforce their interactions, and generally create a more native feel for web applications. However, if these animations have poor runtime performance and cause application to lag, work slowly, then instead of improving UX, we achieve the opposite effect. So let's take a look at a few techniques that we can use to make sure that our animations run smoothly every time, even on low-end devices. First of all, if an element will be animated, but it doesn't accept any input from the user, then we can use pointer event none CSS property to let browser perform some micro-optimizations under the hood. We can also use will change property to let browser optimize things further. However, we should be aware that as a result, the element will be promoted to a separate layout layer. This is a very expensive operation, so it's important to use will change property correctly. We should never use a wildcard selector for the elements or all for the value, and instead apply it only to the elements that we know will change. Also, for optimal performance, it is recommended to add will change property right before animation begins and remove it after it finishes. So, for example, if we animate element on click, it's a good idea to add will change property on hover. The most impactful optimization that we can make, though, is to animate only opacity and transform properties. When browser renders elements, it usually does so in 3 steps. It lays things out on the page, paints the color on top of it, and then applies transform adjustments during composite step. Animating most CSS properties will result in browser going through all 3 stages for every animation frame. But if we animate only transform and opacity, then the browser will have to do only the last one. Even more, first 2 steps run on the main JavaScript thread, whereas the last composite thread runs on a separate GPU-accelerated thread, which means that by animating opacity and transform properties, not only do we get smoother animations, but we also don't have to fight with the rest of our app for the time on the main thread. And sometimes it may seem that we need to animate other properties, but we still can get away with just transform animations. When we want to animate the size of the element, we can use scale counter-scale technique. For example, if we want to animate the height of the element, instead of animating height, we'll apply scale Y transformation. As a result, the content of this element will get stretched out. And so to counter that effect, we'll wrap the insides into another container and apply inverse scale Y transformation to it. When we need to animate both size and the position of the element, we can use flip technique. The way it works, it remembers the bounding boxes for all animatable elements in the start and end position of the animation, then calculates the difference between them and uses scale and translate transformations to run the animation. There is a slightly more technical details to it, but most of the time, we don't really need to concern ourselves with it and just take an off-the-shelf library that implements it. Finally, if you animate with React, make sure to use a library that supports transient updates. And that means that it can animate DOM elements without causing the whole component to re-render. And 2 good examples of such libraries are React Spring and Framer Motion. Anyway, that's all I have time for. If you want to talk about web animations, you can find me in a break, and I'm happy to answer your questions. Thank you.